Hey guys, welcome back. We got day 35. Let's talk about neutralization. And neutralization is pretty much an acid-base reaction. So we're talking acid and base reactions. And so we're going to have an acid, and I'll define acid in a second. Acid plus base produced salt and water. Let's give you an example of one first, and then we'll go into the definitions and more detail. So an acid is that's common is HCl, aqueous acid, NaOH, aqueous base, going to NaCl, a typical salt, and water. And if I'm rewrite this, H, which makes it an acid, HCl, aqueous, plus NaOH, aqueous, we get to go to NaCl, my salt, and H2O, or HOH, as I'm going to write it. Oh, that's green. Let's write it purple. There we go. HOH, liquid. So as you can see, it's a double replacement, or depending on book, double displacement reaction. However, it's special because it's acid-base. Its acids are pretty typically clear and colorless. Sometimes they can get yellowish and whatnot, but they're pretty clear, pretty colorless. Bases, pretty clear, pretty colorless solutions. Salt water, clear colorless solution. Water, clear and colorless. So there's very little evidence of a chemical reaction, which we'll get into how we determine if there's a reaction or not in a second. So acids. Acids are something that produce H plus or H3O plus in solution. And that is the Arrhenius definition of an acid. That's the Arrhenius. So H plus or H3O plus, H3O plus, hydronium, and H plus, same thing for our purposes. And then types of acids, you can have monoprotic acid, HCl, diprotic, H2SO4, triprotic, H3PO4, just how many protons come off. So, for example, we have, let's say, HF, HNO3, H2SO4, H3PO4. So 1, 2, 3 protons that come off in solution. Now, when we have a diprotic acid like H2SO4, it's actually 2 steps. So you have H2SO4 going to H plus and HSO4 minus, and that's step 1. And then step 2 will be HSO4 minus going to H plus SO4 3 minus. For phosphoric acid here, H3PO4, that would have 3 steps for each proton coming off. And it's always easier to remove the first proton than the second proton. And as you know, sulfuric acid is one of our 7 strong acids from before. Now, just so you know, technically speaking, only one is strong. This is weak. No, it's not that weak, but it's closer to 1 than it is to 1,000. But it's weak. We don't need to worry about that in Chem 1, though. That in my class, you're not going to worry about that. Just treat H2SO4 as a strong acid. Chem 2, we change. Those are acids, according to the Arrhenius definition. There's more definitions, but in Chem 1, we only do the Arrhenius definition. Base. According to the Arrhenius definition, a base produces OH minus in solution, such as NaOH produces Na plus and OH minus. Other one would be like strontium hydroxide that has 2 hydroxides. And that's important when we talk about acid-base chemistry. Okay. So when we talk about knowing when this reaction happens, so let's use nitric acid and strontium hydroxide. So I have HNO3, 2 of them, aqueous, plus SrOH2, going to SrNO3, 2, and 2H2O. Okay, so how would I tell when this is done? All right, how would I tell when this is done? Well, first, what is the complete ionic equation? That would be 2H plus, 2 nitrates, plus strontium ion and 2 hydroxides, going to strontium and 2 nitrates and 2 waters. Okay, how did I know that? Yeah, how did I know that? How do you know that? Well, nitric acid is a strong acid. So that means it dissociates completely in solution. Strontium hydroxide is a strong base. Also, it's ionic and aqueous. Strontium nitrate is ionic and aqueous. So I know they all separate in solution. Water, of course, is a liquid, so it stays together. So my net ionic equation then, 2H plus 2OH minus going to 2H2O liquid. And that's my net ionic equation. And so when we're making water, water is clear and colorless. How do we tell? Well, we do it in a method. The method is called a titration. So our method or procedure is called a titration. And that is where we have a substance in a solution of known concentration. So we have a substance in a solution of known concentration, and a lot of times we call that the titrant. And that is reacted with another substance in a solution of unknown concentration, which is typically called the analyte. Okay, so let me write that out. So we have the titrant, and the analyte. Okay? And so a picture of this, a lot of times how we set this up, we have a ring stand in the lab. There's going to be a flask or a beaker. Then there's a clamp with this big long glass tube. Has graduations, has a basically a tap you can open. Has all these lines on there. It starts off at 0. Ours in our lab go to 50 milliliters. And my titrant is in here. My analyte is there. And we're going to put our titrate into the analyte until we get something called the equivalence points. And this is where the moles of hydroxide equal the moles of H plus or H3O plus. The moles of analyte equal the moles of titrant. So we have equal moles. Now we'll use something called an indicator. So it's signaled by an indicator. And what is this indicator? It's a dye. It's basically a chemical dye that changes color, right? And it changes color when it actually has to do with the pH, which we cover in Chem 2. So, but it changes color. It changes color when the reaction is complete. So, in Chem 1, a lot of times we'll use sodium hydroxide as my titrant in the burette. This apparatus up here is called a burette. And so that's where my known is, sodium hydroxide, and my unknown would be, let's say, vinegar, which is a solution of acetic acid, and my indicator will be phenolphthalein, and it goes from colorless to pink. As soon as it turns pink, we're done. It's kind of fun. So that's a titration. That's a acid-base reaction. That's how we tell it's done manually. And to recap what we've learned. Acid produces H plus or H3O plus in solution. Base produces hydroxide in solution. Acid, base, salt, water. It's a double replacement reaction with no evidence of a chemical change. So we use an indicator to tell when it's done. We got to know our strong acids, which are, right, recap, 7 strong acids. HCl, HBr, HI, H2SO4, HNO3, HClO4, and HClO3. Strong bases, right? Pretty much would be NaOH and KOH. However, you also have lithium hydroxide. You would technically have rubidium hydroxide and cesium hydroxide. You also would have magnesium hydroxide. Right, group 1 and group 2, calcium hydroxide, strontium hydroxide, and barium hydroxide. Just know another common strong base is CaO, is lime. Okay, so there are strong acids, strong bases. Weak acids or anything else, your weak base is NH3 and its derivatives. So that means anytime I have N, if it's a lone pair, that's what I mean. It doesn't matter what X, Y, or Z are. It can be H's, it can be other things. That's a base. So that's acids and bases in Chem 1. Hope that works for you guys. Take care. We'll see you next time.